The latest release of Argo CD is out, version 2.11. This release contains over 32 new features, 40 bug fixes, and 49 documentation updates. I'm personally pretty excited about this release because it contains improvements to features that I've personally struggled with, and I'm really excited to share with you. In this video, I'm going to go over a demo of the top 3 features, in my opinion, and talk about 3 other features that I think are worth noting. The best part of this is that you can try out these demos for yourself with a code space that I've created and will link down in the description. I'm Nicholas Mori, a senior developer advocate at Acuity. I'm happy to connect on LinkedIn and talk about anything cloud native. You'll find a link in the video description. Acuity is the company founded by the creators of the Argo project. And they're also the creators of the Acuity platform, which allows you to treat Argo CD like a single piece of infrastructure rather than many Kubernetes resources. It's similar to how you don't need to worry about the underlying compute and networking infrastructure to use Kubernetes from a cloud provider. So instead of becoming an expert on the components that make up Argo CD, you can focus on the reliability and business value of your applications. If you'd like to try out the demos that I'm going to show in the rest of this video, you can do so by going to the repository here that I'm going to link in the description of this video, and you can spin up a GitHub code space which utilizes the dev container configuration here to spin up an entire environment, including a Kubernetes cluster and an Argo CD installation on version 2.11, where you can go deploy the applications and test out the new functionality for yourself. So the first feature we're going to talk about is the ability to prune resources in the reverse order of sync waves. I think this one is going to have the biggest quality of life improvement for users of sync waves because this is how you would expect the functionality to work, but the reality prior to 2.11 was a little different. So when Argo CD executes a sync operation, it does so in 3 phases: the pre-sync, sync, and post-sync. And then within each of those phases, you can have one or more waves. So sync waves are configured using this annotation, the argocd.argoproj.io/syncwave, this annotation on the resources that Argo CD is deploying. And by default, all resources are on sync wave 0. Therefore, a sync wave of -1 will get synced before all other resources that don't specify the annotation. So these sync waves that run within each phase of a sync of an application are often used to ensure certain resources are healthy before subsequent resources are synced. So therefore creating them in the correct order. So for example, custom resource definitions, CRDs, should be created before the custom resources themselves that reference those CRDs. Another common example that I'm going to use in the demonstration today is syncing the namespace before all other objects that rely and are going to live in that namespace. Now, by default, Argo CD will apply namespaces before all other resources in the same wave. However, if you are using negative sync waves, for example, waves to apply resources before all other resources on the default wave of 0, then the namespace must also be created in the lowest wave. You might be thinking to yourself, well, what about the create namespace sync option? Won't that ensure that the namespace exists before starting the phases? It does. However, Argo CD doesn't delete namespaces created by the create namespace sync option when the application is deleted, which is why you might want to include the namespace in the manifests instead of using that sync option. And finally, another example would be to ensure that an operator is synced and healthy before the resources that that operator consumes. So like the Prometheus operator, for example, making sure that the operator is up and running before you put the actual custom resources that that operator is going to consume into the cluster. Now, prior to Argo CD 2.11, sync waves were not respected when deleting an application. Instead, Argo CD tries to delete everything at once. So when an application is deleted, the order of the sync waves is ignored, which causes issues with the same resources that need to be created in a specific order typically they need to be deleted in a specific order as well. So it's common that the operator would get deleted before the resources it manages, which those resources typically have blocking finalizers, like this example, that require that the operator be the one to clean up those resources, which means that the application would be stuck deleting because the operator was deleted first before the resources that rely on that one based on the finalizers. So the expected behavior by most users would be for the sync waves to be respected in reverse order. Now, we can test this out for ourselves on this example application, which includes a number of sync waves and sync phases. So the namespace is created on sync wave -1, so before all other resources that don't specify the sync wave annotation. Then we have a job that runs on the pre-sync phase. We have another job that runs on sync wave 1, and then the deployment runs on sync wave 2, which means that that job would happen before that hook. And then ultimately we have a final job on sync wave 3, which would happen after the deployment is synced on sync wave 2. And we can get a feel for this by syncing the application. So this is the already existing expected behavior, that the sync wave 1 resources will get synced first, and then the sync wave 2 resources, the front end and the back end, and then finally the sync wave 3 resources. After this is done syncing, it'll show synced and healthy. Now, that's the already existing behavior, what you would expect to happen. The new behavior here is that when I delete this application, because my namespace has a sync wave of -1, it is going to be the last resource to be deleted. So when I go and I run a foreground delete on this application, you'll see that the front end, the back end, all the jobs got deleted, and now it's finally deleting the namespace, which ensures that all the resources that rely on that namespace are removed and deleted first. This prevents these issues of an application getting stuck deleting because there's a resource that can't be deleted normally because the finalizers dictate that an operator needs to be the one to delete it, but Argo CD has already deleted that operator. The next new feature in Argo CD 2.11 is the ability to auto-label clusters with their related Kubernetes information. So how this works is that by adding a label to the secret that represents the cluster in Argo CD, if we add this auto-label cluster info true annotation on the cluster secret, Argo CD will see that and then update the cluster secret with the Kubernetes version of that cluster. So the benefit of this functionality is that you can use that cluster label in application sets to create applications either based on the Kubernetes version of the cluster or to use the version of that cluster in the Helm values for the application generated by that application set. Now, in order to demonstrate this with an Argo CD instance that's referencing only an in-cluster connection, is that we have to trigger it to create the cluster secret. So the in-cluster connection information is created automatically when Argo CD is deployed. However, it doesn't automatically create the declarative configuration, the Kubernetes secret in the Argo CD namespace for the in-cluster connection. Now we can trigger the creation of the secret by running the following Argo CD command, which adds the cluster based on the current kubectl context named k3d dev, specify that this is the in-cluster destination, and then we're going to add the auto-label cluster info annotation to the cluster as a part of this command. And when we do so, it'll make sure that the service account cluster role bindings are all present in the cluster. And then if I run kget secrets in the Argo CD namespace, we'll see that there's now this cluster, the service address secret in that namespace. And if we look at that secret, you'll see that there's the annotation that I added when I ran that Argo CD command, as well as the Argo CD controller has added the Kubernetes version of this cluster as a label to the cluster secret. So now that that cluster secret has that label and is present in the cluster, if I go over to Argo CD here and we look at the whalesay Kate's version application set, we'll see that we have a generator, a cluster generator, that looks for clusters that have that Kubernetes version label that Argo CD adds present on that cluster. And then it uses the contents of this label, so the value that contains the Kubernetes version, in the Helm values of the application to say, use this Kubernetes version in this value for the Helm chart. And so the result is that the application set has created one application for the cluster that contains that Kubernetes version label. And then in that application, it's used the Kubernetes version in the values files, which translates to the Docker say output showing the Kubernetes version for the cluster that that application is running on. And this is demoware to demonstrate that I've been able to pass that Kubernetes version into this application, but you could use it for a multitude of reasons. One interesting example is that you could take a tool like Kube No Trouble and only deploy that tool to clusters running a specific Kubernetes version to get back information about potentially deprecated APIs in the next Kubernetes version for clusters that you're looking to upgrade. So the next feature that I want to demonstrate is related to applications running multiple sources. So the initial support for multiple sources for applications was added in Argo CD 2.6, but there were several places in the CLI and the UI where support hadn't been added for multiple sources. So the underlying functionality was present and working if you deployed an application with multiple sources, but the CLI and UI experience wasn't fully up to date. If you're interested in learning more about why you would want to use an application with multiple sources, you can check out this full demo, which I'll link in the description down below, on how to manage remote Helm values files using this multiple sources functionality. So in Argo CD 2.11, support has been added for multiple source applications in several areas of the Argo CD CLI. So I'll be using this example multi-source application, which includes a Helm chart from a repository that I don't maintain and a values file from a source that I do maintain, which is then referenced in the Helm values files of the chart that I'm pulling in. So probably the best example is the Argo CD app history command, where prior to Argo CD 2.11, you would simply get no output on the revision and the source information. You would simply get the date and the ID of that history. Now, in 2.11, for a multi-source application, you will actually get a breakdown of the different revisions for each source included in that application. Another good example is the Argo CD app set command, which prior to Argo CD 2.11 was not able to differentiate between multiple sources in an application to determine where to set that parameter. Now, with Argo CD 2.11, you can set the parameters based on a specific source position. So you can specify whether it's the first or second or fifth source in that application that you want to set a particular parameter on. The next feature I want to talk about is improved performance for monorepos. So in the context of Argo CD, the monorepo refers to a Git repository that many, if not all, of the applications refer to. So when there is a new target revision for that monorepo, it triggers the cache of all the applications to be invalidated. The repo server will then have to regenerate the manifests from the source for each of those applications, despite the fact that in the new revision, there may have been no changes to the specific path that that application references, but because they all reference the same source and target revision, the cache has to be invalidated. So to get around this behavior, users can add the Argo CD argoproj.io/manifest generate paths annotation, which contains a list of the paths within the Git repository that are used during manifest generation for that specific application. However, the annotation is only respected when a Git webhook was configured in Argo CD for that repository, because the event from that webhook contained the files that had changed. Now in Argo CD 2.11, the manifest generate paths annotation is supported in normal sync operations, which improves both the speed and user experience of monorepos within an Argo CD installation for users that don't configure or don't have a Git webhook configured. So now, even without the Git webhook, users will experience fewer sync operations for applications that are not affected by any files found in the latest release, assuming they've configured the manifest generate paths annotation. And the Argo CD history UI will only list the commits that actually affected the application. This is a huge improvement as long as you know to specify the manifest generate paths annotation. So if you're a monorepo user, you've got many applications referencing the same Git repository, the same source and the same target revision, then it's crucial that you specify this annotation and list the paths that are actually relevant to that application. You might assume that it should be as simple to use the source path of that repository to determine which paths need to change. But the reality is that an application might be affected by paths that are outside of the one that it's specifically referencing, because the customization might be referencing other folders outside of that one, or a Helm chart might be affected by other folders within the same repository. So by specifying this manifest generate paths annotation, you can ensure that the application's cache is only invalidated when files relevant to it are actually changed in that Git repository. Now, this might be the smallest change of Argo CD 2.11, but it's also an important one to note. The applications and any namespace feature has been promoted from beta to stable. So if you're not already familiar, since Argo CD 2.5, application resources can be managed in namespaces other than the control plane's namespace, which is typically Argo CD. Administrators can define a certain set of namespaces where applications can be created, updated, and reconciled from. This allows ordinary Argo CD users, for example, the application teams, to own the declarative management of their application resources, implement the app of apps pattern, and more without the risk of privilege escalation through the use of another app project that they're not assigned to, that would then exceed the permissions granted to the application teams. Also, this way users can configure notifications for their Argo CD applications in the namespaces that they own. It's been a bit of a long journey since Argo CD 2.5, and there have certainly been a number of bugs and improvements and edge cases caught for this feature, but it's really exciting to see it moved from the beta to a stable status to show that the project is confident in this feature and of its functionality. So I just talked about possibly the smallest change in this release. Now I'll talk about the most subtle feature improvement. So this is the history and rollbacks UI for an Argo CD application. If you look at this, can you determine what is different? It's pretty subtle. So for teams that have Argo CD applications with autosync disabled, which is a common pattern for production environments, they want to know which person started a deployment, who clicked the sync button. This information can be really crucial for tracking down what happened during an incident. Why did a particular application sync at a certain time? And when it's not automated, that means that there was a person behind the click of that button that you can talk to get context for why a sync was initiated. So the new feature in Argo CD 2.11 adds a new field to the history UI, which specifies who initiated a sync. So because I'm logged in as the admin user, it shows admin here. But if I was logged in through SSO, it may show the user ID from my SSO provider here. And this is great because now you can go and talk to who initiated a sync. So in addition to all the context of what revision you were synced to and how long it's been active for, you can also tell who decided to initiate that sync at that time. This new field was implemented by adding a new field to the status of applications. So in the status of a live application, you'll see the history here. And in each entry for the history, you'll see who initiated that sync. So if it was initiated by the automated sync policy, you'll see automated true. But if it was initiated by a user, you'll see their username in that entry for the history. The last feature I want to talk about is related to the performance of the application controller. So this is a bit of an advanced topic, so I'll give some pretext. When you have a single Argo CD instance that is managing multiple clusters, there is the capability to shard application controllers and have each shard be responsible for specific clusters, rather than having a single application controller managing all of them. Now, the primary sharding algorithm, which is used to determine which shard is responsible for which clusters, distributes clusters based on hashing their IDs. The challenge with this algorithm is that it's not always uniform. It results in some shards managing many clusters while other shards could be managing just a few. Additionally, if the clusters aren't uniform, so for example, you've got some clusters that are large, managing many applications, but others manage only a handful of applications, this isn't taken into consideration, which results in some shards being under heavy load while others sit idle. So in this example, we're using the application controller in the stateful set configuration. And so right now I only have one controller, which means this one is responsible for all of the applications within the cluster. Now I can shard this application controller so that there are multiple instances of this stateful set or multiple replicas within the stateful set managing applications. But the default algorithm isn't necessarily going to balance the clusters across those shards in a way that's even. So the addition in Argo CD 2.11 is now the sharding cache has been updated to include data on the number of applications managed by a cluster, which this is one of the main indicators of how much load an application controller is going to be under, how many applications it's going to be managing. This will allow future sharding algorithms to distribute clusters between shards based on the number of applications that they manage. This is based on some really great work from the team over at Canoe, who have been running benchmarking on Argo CD and are continuing to push the limits of how far the open source Argo CD can scale. The application controllers are one of those major pain points when scaling Argo CD, understanding how to shard them, make sure that they're even and managing the correct clusters, and just managing the number of shards as your number of clusters grow. This is one of the main advantages of running Argo CD on the Acuity platform, is that the Acuity platform manages the sharding of the application controllers for you using the hybrid agent-based architecture. This allows you to put an application controller in each of the clusters that you're going to be managing while still maintaining that central Argo CD UI for a view across all of your clusters. If you're interested in learning more about how the Acuity platform can solve the operational burden for Argo CD in your team, check out the links in the description down below, where you can start a free trial for yourself and get a hands-on experience with the innovation provided by the Acuity platform. Thank you for watching this video on what's new in Argo CD 2.11. If you're new to Argo CD and you want to learn more, check out the link to our free self-paced course for an introduction to Argo CD using Helm charts. If you're a more experienced Argo CD user and you're experiencing difficulties scaling and managing Argo CD in your organization, check out the Acuity platform, where you can let your application developers focus on creating and delivering business value while you on the platform team ensure reliability and predictability with the Acuity platform. Thank you, and I'll catch you next time.